Hello students. In this video, we're going to explore the fascinating topic of stars and the solar system. Let's start with the solar system. Our solar system is a remarkable structure within the universe, consisting of the Sun, 8 planets, and various other celestial bodies like moons, asteroids, and comets. The Sun is the central star, the powerhouse that provides the energy necessary to sustain life on Earth and drives the movements of all the planets and other objects within the system. Understanding the solar system helps us gain insights into the origins of planets, the potential for life elsewhere, and the complex interactions between celestial bodies. The planets in our solar system can be classified into 3 main categories based on their characteristics: terrestrial planets, Jovian planets, and dwarf planets. Terrestrial planets, also known as inner planets, include Mercury, Venus, Earth, and Mars. These planets are primarily composed of rock and metal, and they have solid surfaces. They are smaller and denser than the outer planets and have relatively thin atmospheres. Earth, as we know, is the only planet known to support life, thanks to its dynamic surface and life-sustaining atmosphere. Moving outward from the Sun, we encounter the Jovian planets, or gas giants, Jupiter, Saturn, Uranus, and Neptune. These planets are massive compared to the terrestrial planets and are composed mainly of hydrogen, helium, and other gases. They lack a solid surface and have thick atmospheres with extreme weather conditions. Jupiter, the largest planet in our solar system, is known for its Great Red Spot, a gigantic storm that has raged for centuries. Saturn is famous for its spectacular ring system, while Uranus and Neptune are known as ice giants due to the presence of icy materials in their composition. Finally, we have dwarf planets, which include Pluto, Ceres, and Eris, among others. Dwarf planets share some characteristics with regular planets, such as orbiting the Sun, but they are smaller and haven't cleared their orbits of other debris. Pluto, once considered the 9th planet, was reclassified as a dwarf planet in 2006. Now, let's focus on Earth's movements and seasons. The Earth's rotation and revolution are the primary reasons we experience day and night and the changing seasons. Earth rotates on its axis, completing one full rotation approximately every 24 hours. This rotation is what causes day and night. The side of the Earth facing the Sun experiences daylight, while the side facing away from the Sun experiences night. In addition to rotating on its axis, the Earth also revolves around the Sun in an elliptical orbit. This revolution takes about 365.25 days to complete and is responsible for the seasons. The tilt of the Earth's axis, about 23.5 degrees, plays a crucial role in creating the seasons. When one hemisphere is tilted towards the Sun, it experiences summer, while the opposite hemisphere, tilted away, experiences winter. During the spring and autumn equinoxes, both hemispheres receive roughly equal amounts of sunlight, resulting in nearly equal day and night lengths. Moving on to the Moon, Earth's natural satellite, we find a celestial body that has captivated human imagination for millennia. The Moon does not produce its own light but reflects the light of the Sun. Its phases, new moon, crescent, quarter, gibbous, and full moon, are the result of the changing angles between the Earth, the Moon, and the Sun as the Moon orbits Earth. One of the most awe-inspiring phenomena involving the Moon is the lunar eclipse, which occurs when the Earth comes between the Sun and the Moon, casting a shadow on the Moon. During a total lunar eclipse, the Moon can take on a reddish hue, often called a blood moon, due to the scattering of sunlight through the Earth's atmosphere. A partial lunar eclipse occurs when only a portion of the Moon is covered by Earth's shadow. On the other hand, a solar eclipse happens when the Moon passes between the Earth and the Sun, blocking the Sun's light either partially or entirely. During a total solar eclipse, the Moon completely covers the Sun, casting a shadow on Earth and briefly turning day into night. An annular solar eclipse occurs when the moon is slightly farther from the Earth in its orbit and does not completely cover the sun, leaving a ring of sunlight visible around the moon. The tides are another phenomenon closely tied to the gravitational pull of the moon. Tides are the rise and fall of sea levels caused by the gravitational forces exerted by the moon and, to a lesser extent, the sun. As the Earth rotates, different areas experience high and low tides. Spring tides occur when the sun, moon, and Earth are aligned, resulting in higher than usual tides. In addition to the planets, our solar system is home to a variety of celestial bodies, including asteroids, meteors, and comets. Asteroids are rocky objects, mostly found in the asteroid belt between Mars and Jupiter, while meteors are small particles from space that burn up upon entering Earth's atmosphere, often visible as shooting stars. Comets are icy bodies that develop glowing tails as they approach the sun, creating spectacular displays in the sky. Lastly, we have satellites, which can be either natural, like the moon, or artificial, like the many satellites orbiting Earth used for communication, weather forecasting, and scientific research. Artificial satellites have become indispensable tools in modern life, providing crucial data for navigation, environmental monitoring, and even space exploration. Now, here's a question for you to test your knowledge. What kind of eclipse occurs when the moon completely covers the sun? Please share your answer in the comments. The complete curriculum for Class 8 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.